everyone. I'm currently studying arithmetic. No, not arithmetic. What do you call it? Geometry. There it is on Khan Academy, because I am mathematically challenged and I never learned math properly. And as you can see, I'm already like some ways through the lesson. I finished the arithmetic section, which was like grade 2 math, I guess. And now I'm on to, what do you call this? Geometry. See, I can't even remember the name. It's that bad. So yeah, here I am on the measuring and drawing angles section. So let's take a look at this. I thought it might be fun to record this because I'm planning to do this for a while, and I thought it might be interesting. Maybe to other people who suck at math and maybe want to study math, but they're like afraid because when you're an adult studying elementary math or elementary anything, it can feel a little embarrassing. Anyway, but watch me make mistakes and in my humility attempt to solve these problems that a 10-year-old could probably solve quite easily. Pardon me. Okay, let's take a look. So, I just finished watching these videos here, and now I'm going to do the measuring angles exercise. So let's check that out. Alright. So, have to measure the angle in degrees. Okay, so everyone remember protractors? Okay, I don't. Okay, so that's obviously 60 degrees, because it says right there. Okay, cool, great. This actually gives me some anxiety, honestly. Okay. Which image show a correct way to measure an angle with a protractor? Well now, look at this. Okay, oh man. Okay, this one, obviously. Yeah, no. No, Timmy, that's wrong. Oh, there's more than one answer. Oh, it says choose 2 answers. You got to read the question carefully, you see. Show a correct way. Is this correct? B is correct? Wow. I guess I guess it is, because you could work out the difference between these two. Oh, that makes sense. Okay. Huh, see where I am with this? Okay. Measure the angle in degrees. That's 100. Okay. Very nicely says that for me. Thank you very much. And let's see. Measure the angle in degrees. That's 80. Okay, cool. Easy peasy. All right. Cool. Easy. Okay. Looks like I know more than I thought I did, maybe. Alright, well, I'm going to watch another video, so I'll pause the recording here, and then we'll pick it up when I'm doing the exercises. Okay, so we're back here with constructing angles review. So I just watched a video on this. By the way, sorry for any mic pops, but I don't really know how to solve that problem right now. I will look that up later. Anyway, so let's just look at this. Okay, so constructing angles. Basically here, well, you'll see. We can use a protractor to help us construct an angle of a given amount of degrees. Cool. Example, construct a 65-degree angle. To make a 65-degree angle, we move the middle dot of the protractor to the vertex where the 2 rays connect the angle. Okay, oh, I guess it's just an image. I can't actually do anything. Okay. To make a 65-degree angle, we move the middle dot of the protractor, middle dot, to the vertex. There it is. That's the vertex where the 2 rays connect. These are rays. These emanating lines. Rays. I guess that's what they mean when they say ray tracing. I don't know. I'm also learning how to make games. That's why I'm learning math, actually, but it's a long story. Anyway, next we line up one of the rays on the 0 line of the protractor. That's the 0 line. Okay. Alright, because this is not... I don't know. Okay, whatever. We then we move the other ray around until it is lined up with the 65-degree measurement of the protractor. So we got... That's our first line there, and then we move that one over like tuck, 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 and then it goes over that way. So it's... Oh, okay. Oh, right, we're constructing a 65-degree angle. Okay. Yes, that is what we are doing. The angle will look like this when the measurement is 65. There it is, 65, right there. 0, 65. Note the angle can be rotated in any direction, but the angle between the two rays must look like this. Okay. Must look like this. Yes. That makes sense. And then that's it. Okay, let's practice this. So this is cool. Like Khan Academy has all these things, these little virtual tools you can use. So you don't actually like need a physical protractor. I was afraid I'd have to go and buy like a geometry set again. Of course, I have one, you know, back home in Canada. I'm living in South Korea right now, so you know I have one back in Canada, but obviously I never went to elementary school in South Korea, so I don't have a protractor here. Anyway, okay, so I want to make a 40-degree angle. Should be pretty easy. What can I move? Oh, there we go. Oh, yeah, here we go. Look at this. Okay, let's just make this like flush, like perfect. Yeah, there we go. So we got this guy at the 0, and then we got this guy at the 4. That should be correct, right? Okay, cool. This is like kind of just the review, so I don't get any like points for doing this. Next question. Construct a 130-degree angle. Again, this is obviously pretty easy stuff, but it's all about building confidence, you know? I literally have, well, I had, before I did the arithmetic section, like no confidence in my math skills. And that's what I'm trying to do. I'm trying to build that, so I'm sure y'all can appreciate that. Number 130. Okay, 130. Yeah, that looks right. Let's see. Cool. All right, easy. And 90 degrees. Well, that's like the most straightforward angle, in my opinion. Okay, yeah, let's just get that flush. Perfect. And then that. Okay, cool. Wow, that ain't no thing. Okay, let's get out of here. So, let's go to, yeah, let's do this guy here. I think I'm ready. Think I'm ready. Okay, so, yeah, this is a 90-degree angle we need. Move this guy over here. Move this guy over here. Check. Easy. Okay. This shouldn't. Ooh, we got a circle protractor here. I think that's what it's called. Oh, can I move this thing? How does this work? Oh no. Is this? Oh, I can move the line. Okay, that's cool. Move the vertices, the vertex. Vertex. I don't know if that's right. Oh my god. Okay. So we want a 15-degree angle. We got this guy at 0, and we've got this. That's 15, right? Yeah, there we go. Look at this. All this. Okay, and now we can move. So you can't move the full circle one. You can only move the half. That's okay. So construct a 50-degree angle. That's easy. And there we go. Look at that. It's a bit of fun. Okay. Oh, okay. We got another full circle here. a 360 degree protractor, I guess. I don't know what you call this thing. Officially. Construct a 130 degree angle. Oh, that's pretty simple. Look at that. Cool. Okay. Getting more confident here. It's my first time doing this particular exercise. But again, it's fairly straightforward, obviously. Okay, that's 55 degrees, I think. Yep. Okay. Yep. Getting easy. I guess it was always pretty easy, but... There we go. 30 degrees. Yeah. Okay. And... Okay, 100 degrees. Let's go. Wow, look at that. I am the champion of geometry. Okay, no, not yet. Not yet. Alright, now we've got a quiz. I'm hoping to try to finish this whole... could take a while. Okay, well, in any case, let's get to this quiz here. It says 12 to 15 minutes, but, you know, I don't think it's going to take me this long. Let's see. This is pretty intuitive stuff here, and very, you know, rudimentary. Okay. 80 degrees. I'm going to do this pretty fast. Let's speed run this. Yeah, look at that. Oh my god. What is this? What is this arcane diagram here? So, which angle refers to the same angle as DAC? DAC. So they told me in a previous lecture that the vertex, the vertex, I think that's what that's called now, goes in the middle of this designation. So it's like DAC or CAD, Canadian dollars. Okay, so it's this one. Yeah, so you have to like find the angle in there. Look at the angle shown below. Oh, it's so... Oh, so this caught me off guard before, because like this, obviously this is very acute in here, but actually what you're looking at is this. Now I'm sure like most people know that, but I didn't, or like I wasn't paying attention or something, and I just made all these mistakes before. Based on this, so yep, that's kind of embarrassing, but whatever. Okay, so what are we doing here? Oh yeah, so what could this be? What could this be? 350 maybe, because 360 is a complete circle, right? Yeah, okay, that makes sense. Which angle measure is greater? So an angle measure in this case, they're talking about like the perceived, or like the degree amount, I guess, of the angle. Does that make sense? Degree amount? I don't even know if that... Does that make me sound stupid? Okay. And this one is obviously greater because it's an obtuse. Maybe the other one looks slightly acute to me. Anyway. Look at the angle shown below. This is like the line. So it's 180, I guess. Yeah, because 180 is like a perfect line. Yeah. Oh, look at that. 100%. So so smart. I guess like my my grade 3 teacher would be really proud of me. Maybe. All right. Now, angles and circles. Okay, so I have some more videos to watch, so probably do that, and I'll come back with some exercises. Okay, so we're back. So now we're doing word problems with, like, circular angles, I guess? Yeah, we're using, like, circular protractors and things, to do like word problems, I guess. So angles and circles. There it is. Okay, that's what we're doing. So, problem 1, caterpillar stands on her head. Okay, And how many degrees does the caterpillar need to be turned to be upright? Huh. Okay. This is like really easy, but I'm actually like confused by this, which is kind of embarrassing. Okay. I don't know the answer right away. Okay, so I'll have to take a look. Oh my goodness. See, this is where I am with this. Like I told you guys. Mathematically challenged, man. I just never really like properly learned these basics. I think that was the problem. Not like trying to hate on my teachers or anything like that. Like I don't necessarily think I had bad math teachers. I don't know. Like when I was a young child, I just like numbers did not make sense to me. All of this stuff, it was just like I don't know. Anyway, now that I'm an adult, I sort of understand why this stuff is important. But when you're a kid, it's like it's so abstract. You're like, what? Like this? Oops! Oh, there's my microphone settings. Okay. Anyway, what's up? So, okay, this doesn't really help me. Yeah, I don't know. It's interesting, like this like this is like a little bit different, right? This is like at 400. This is like 200. And this one, I'm sure there's like a very obvious reason for this, but I have no idea what it is. Yeah, this is more what I was expecting. Anyway, I don't know. Okay, so oh, it's like 180, right? It's like 180 degrees, right? Oh, stupid. Let's see if I'm wrong. I'm gonna. Oh yeah, okay. Jeez. You know, I played snowboarding games, right? 180. You know, like, back in the day. 360 degrees. Stale fish air. Something like that. Problem 2, oven. Okay, if Ariana turns the stove dial to 135 degrees to the right, what setting will the dial be on? So sorry, there's like some cooking going on back here. Anyway. This microphone just picks up everything, so bear with me. So if Ariana turns the stove dial to 135 degrees to the right, so that's this way, what setting will the dial be on? So that's 90 degrees is low heat. 90 degrees, okay. Okay, I don't have like the number sense to calculate that in my head. Medium low. Okay, well, 180 would be medium heat, so it's probably medium low, right? See if that's right. Yeah, okay. And then this tells you, yeah, medium heat. Okay, cool. I'm not totally useless at this. Problem 3, directions. Melissa walks 3 blocks south, and she turns 450 degrees right, clockwise, and walks 1 block. So she walks 3 blocks south, and then, so it's like 1, 2, 3. Then she turns, so she's south. Okay, 45 degrees to the right. Ding. That's 45, right? Right? No, that's 90. Okay. I guess it's this. Okay. And what direction does Melissa end up facing? I guess southeast? Oh, is it like her right or my right? Oh, God. Because if it's her right... See? Okay, if it's her right, it's southwest, right? Oh, my God. But if it's my right, it's southeast. See... This is the way my brain works. I'm just like this neurotic person where I'm just like, which one is it? All right, let's try southeast. Let's see if it's my right. No, it's southwest. It's her right, I guess. Right? Okay, it's kind of embarrassing, but You know, it's because it's not clear. They don't tell you. You just have to assume. But I don't like assuming. I don't like assuming. Assuming gives me anxiety. Because, like, what right do I have to assume anything in this world? Anyway, problem 4, pizza. A pizza is cut into 6 equal slices. There it is. Delicious. How many 1 degree turns does it take to make 1 slice of pizza? Okay. 1 degree turns. How many 1 degree turns does it make? Or does it take to make 1 slice of pizza? 1 degree turns. I don't even really understand this question. What do they mean? What's a 1 degree turn? Like, okay, so what's happening in my head right now is, like, I'm looking at this pizza and I'm trying to, like, figure out, like, I think a 1 degree turn is like this, like beep, or like beep, 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 boop. And I don't think that's what they're asking me. Maybe it is. See, this is how unsure of myself I am. So, yeah, I don't know. Like, what could it be? I have no idea. Oh, okay, wait a second. This is easier than I expected. Okay. So this would be like 180 degrees. They're just asking you, like, how many degrees is each pizza, each slice. Sorry. So, I guess like 45 degrees, right? 45? No. Okay, so I don't know what I'm doing. Explain to me, good sir. A full circle is 360. I know that. There are 6 slices. So it's 360 divided by 6. Oh. Yeah, I didn't know that. I feel like that would be very obvious to a lot of people, but not to me. Not to me. So it takes 61 degree turns to make 1 slice of pizza. Okay. Interesting. So the answer is 60. See, I totally misunderstood that question. And this is my problem when I study this, like, simple math. It's like half the time I don't even understand what they're asking me to do. And it takes a few tries to kind of figure it out. Although I usually get there eventually. But yeah, so, you know, if I can do it, anybody can. Challenge problem clock. How many degrees does the hour hand on a clock turn between 7 a.m. to 10 a.m.? Okay. By the way, I'm not pretending to be useless at math. Like, this is genuine what you're seeing here. Okay. So, 7 to 10. Okay. Yeah, what is that? Okay, so how many degrees does the hour hand on a clock turn between 7 a.m. to 10 a.m.? Well. Okay, how many degrees? Oh, okay. So a circle is 360. We can use this, like, very basic formula that they outlined here, I guess, right? Maybe. So the circle is 360. We've got, okay. Well, so how many degrees does the hour hand on a clock need to turn between 7 a.m. 7 a.m. and 10 a.m. Okay. And we've got, can I measure these as, like, 4 or 3 equal parts? So if I did, like, 360 divided by 3, would that give me the answer? Maybe it would. I actually don't know. Well, I could write this out, but I don't know. I'll just use a calculator because Saves time. 360 divided by 3. Let's see if that's the answer. It's 120. That can't be right. That doesn't make any sense. But, or maybe it does. I don't know. Let's check it out. No, it's wrong. Yeah, that did not seem right to me at all. Yeah, explain. Yeah, I don't know. There are 3 hours from, yeah, okay, 3 hours. The hour hand turns 12 of the way around the clock face. So it's 3 divided by 12. We can simplify, or 1 over 4. There's 3, okay. So there are 360 degrees in a full turn. To find 1/4 of something, we divide by 4. Yeah, well, that makes sense. So it's 360. It's 360 divided by 4 equals 90. The hour hand on a clock turns 9 degrees between 7 a.m. and 10 a.m. Okay. Well, I guess that makes sense. So the answer is 90. Okay. 90. This is, yeah. This is like... Yeah, again, like, this is probably very simple for most people, but, you know, I never really learned this. So this is totally new to me, believe it or not. Or maybe I did and I just totally forgot about it, which is probably more likely, actually. Or I just never really understood it in the first place. Anyway, let's try to do some problems here. And then maybe I'll end it here and do something else, because I'm getting tired. Okay. So complete the description of the angle below. So that's x, y, z. Okay, that's that angle of a full turn is 1/4 of a full turn. Okay, so maybe this will make things a little easier to understand. So its measure is 1/4 of 360 degrees. It's 90, yeah. Okay, because it's like a right angle, right? Yeah, cool. Okay, that makes sense. How many degrees are in a 1/12 of a full turn? A 1/12 of a full turn. So a full turn is 360, so we're doing 360 times 12. Yeah, you know what? I should probably write this out, because that'll it's just good practice. Even though I could probably do this in my head, but it would like break my brain. So 360 divided by 12. We're looking at, oh yeah, I could do this with long division, so you can't really see what I'm writing here. Maybe I'll get another camera at some point. But, yeah, 12's into 36, that's, oh, that divides pretty nicely. So that's 3, and then, yeah, and then, that's it, I guess it's 30, right? 30 12s going to 360. I don't know if that's right. 12, so would that be 30 degrees? Am I correct in my... Oh yes, there we go. That actually feels really good. Again, I know this is a fairly simple question, but yeah, you gotta know where I'm coming from here. Like, this kind of stuff would have killed me as a child. How many 45-degree angles does it take to make a full turn? Okay, so yeah, that's just like 360 divided by 45, I guess, yeah. And then, yeah, right? Yeah, so let's look at that. That's like 45, 360. So yeah, one of the benefits of doing the arithmetic course was that I actually learned or was reminded how to do long division, I totally forgot how to do long division. I know in everyday life it's maybe not that important, but like, you use a calculator if you need to make large calculations. But just having that number sense, having that understanding of how everything fits together, I think is, it's very fundamental, right? And I think I was lacking that before. At least that's what doing the arithmetic course taught me. So, anyway, so 45 does not go into 36, but it does go into 360 some amount of times. So I don't know. Yeah. Well, okay. I don't want to be here all day, so let's bring up the old calculator again. Let's just see how much. 45 times, I don't know, it's 3. Let's see. Okay, that's 135. Okay, so that means 45 times 6 is just double that. Oh, that actually might be the answer. Let's see. So 45 times 6, and that's like 270. Oh, wow, we still got a long way to go to 360. Okay. Well, shoot. 45. Again, like, maybe I should know these from memory. I don't know. Okay, what did we do? We did 6. Okay, let's try 8. There it is. Oh, look, it divides evenly into 8. Oh, I didn't even know that. Oh, man. Okay, long way to go. So we're looking at 8, I guess, is the answer, right? Yeah. That's correct. Yeah, great. Okay. Now the circle is divided into 360 equal parts. Point 0 represents the center of the circle. The measure of angle... okay, so we have to determine what is 70 degrees here. 70, okay. Well, that's 0. That's like 180. Right? Divided into point O represents the center of the circle. The measure of... Okay, which one is 70 degrees? See, this is a bit confusing to me because this is definitely like LON is definitely a right angle. NOP is also a right angle. Nope. NOP. The only one that isn't a right angle, which would be 90 degrees, is MOL, but that doesn't look like 70 degrees to me at all. So, yeah, this kind of stuff just like kind of really makes me uncomfortable, if I'm being absolutely honest. Okay. Well, by process of elimination, like again, it's very clear to me that I'm obviously not understanding a fundamental concept here. But let's try LOM. And that's not right. Yeah, I didn't think that was right, but nothing else seems to make sense to me. Okay. Let's just go down the list. MON. Oh my god, it is MON. Oh, I see it now. That's frustrating. Okay. You see? This is how my brain works. This is the problem. Okay. Complete the description of the angle below. Okay, so EDF or... Oh, sorry, no, it doesn't start with E. The vertices is always in the vertex. Vertex. Sorry, that's the word. Vertex is always in the middle. DEF. Okay. So DEF is 1/8. Yeah, right. Because it's like there's 2. Right. These are all fourths, and then there's like 2 sections, so it's 1/8 of a full turn. So its measure is. Its measure is 45 degrees, right? Because 45 is 1/8 of 360. Okay. I think that's right. Yes, confident in that answer. Good. How many degrees are in a half of a full turn. Half of a full turn. Oh, well, it's like 180, right? Yeah. Hey. Yeah, okay, that's easy. And then how many 120 degree angles does it take to make a full turn? How many 120 degree angles does it take to make a full turn? Oh, okay. Yeah, 360 divided by 120. Which should be pretty easy. It's 3. Okay, I don't need to write that down. Okay, cool. Alright, so I got one question wrong. Let's go through this once more, and I think that'll be all for today. But I just really want to get 100% on this, because I know I can. So the circle is divided into 360 equal parts. Point A represents the center of the circle. There it is. And what do we got here? We got D. Oh, no, I don't know. Oh, sorry. What did I just zoned out for a second there? Okay. So the circle is divided into 360 equal parts. We got okay. Point A represents the center of the circle. Oh, okay, we're looking for a measurement of 105, which I'm fairly confident is EAB or BAE. BAE. Bay. This angle is bay. It's a very... No, we're not going down that road. Okay, check. Hooray. Okay, that was easy. Complete the description of the angle below. That looks like a 180 degree angle. And OP is 1/2 of a full turn, so its measure is 180 degrees. Okay, yes. Good. How many degrees are in a quarter of a full turn? Quarter. That's a fourth. That's 90 degrees. 90. How many 30 degree angles? How many 30 degree angles does it take to make a full turn? 30 degrees. Yeah. 30 degrees. That would be 360 divided by 30. And because I'm silly, not silly, no, because this is hard for me, I have to write this down. Okay, so 30, let's do some division here. Yeah, I think I'll rig up like a cell phone or something so you guys can see me like writing down stuff later on. Okay, what's going on here? Doodaloo. So we've got 30. 30 goes into 36 once. That's true. And we go 30, and then it's like 6, and then you bring down the 0, and then so I'm doing long division right now. You can't really see it, unfortunately. Right, and then it's 12. So it's 12. 12, is that right? Yeah, look at that. Huh. Cool. It's all coming together. Okay, the circle is divided into 360 equal parts. Point 0 represents the center of the circle. Yes. And the measure of the angle is 120 degrees. The measure of the angle is 120 degrees. Okay, yes, we want... What is that one? That's... that looks like it could be 120 degrees. Oh, wait, no, that's pretty big, though. But no, yeah, no, that's probably it, right? Or is that just way too big and I'm just ridiculous, or way too obtuse? Because, like, this is pretty close to 90 degrees. But, like, that looks like maybe, like, 100 to me, or, like, 95 or something. But this one here, this looks like it could be our guy. So NOP, let's try that out. Nice. Okay. Complete the description of the angle below. We've got ABC. ABC is 1/3. Yeah, that's right. You got 1/3 of the pi right there. So its measure is, that's half. So it's probably 120, right? Okay. How many degrees is sorry. How many degrees are in 3/4 of a full turn? So 1/4 would be 90 degrees. 3/4 is just 90 times 3. Is that right? Yeah. The 9 times 3 is 27, so it's 270 degrees. Look at that. Finally remembered my times tables. Or mostly. Yeah, that was a big obstacle. I had never really remembered my times tables as a child, so math was really hard because I had to calculate everything in my head, and it took forever. Anyway, that's correct. Yes. Cool. And there we go. Making progress. So yeah, again, I'm aware that this is very simple mathematics. You know, I don't think I'm like a genius or anything by doing this, but you know, it's just I'm trying to build confidence, trying to build mathematical confidence with the basics. Yeah, I was just you know, I think I was kind of scarred by learning math in elementary school and well, public school in general, basically. And so you know, that trauma kind of gave me like a fear of numbers because I just failed so hard at mathematics. It wasn't even funny. And but now here I am trying to develop my skills a little bit. So, you know, and for those of you who don't know, just so you know, I'm only 6% done. I just started geometry yesterday, actually. So, you know, I imagine I could get through this pretty quickly. As I said, I'm pretty sure I can do most of this stuff. It's just that you know, it's like I don't know what I can do. So that's why I'm doing this. Anyway, I'm going to stop rambling and join me again next time for some more basic math. Oh, stop.